Hello everyone, welcome to this video. In this tutorial, we're going to learn how to balance chemical equations using the algebraic method. When you are given chemical equations, there are two basic methods that you can use to balance such a chemical equation if it's not balanced. So before you balance any chemical equation, you must check or you must look for the unbalance or the imbalance in that chemical equation. If actually it is not balanced, then you should balance it. But if you check the number of atoms of each of those elements on both sides of the chemical equation and find that they are all the same, then that chemical equation is actually balanced and you don't need to balance anything there. But you may have some chemical equations which are not balanced at all. So you would need to balance it. The two methods you use are the algebraic method and the trial and error method. For the algebraic method, it's easier and more straightforward because once you solve and get your answer, you can be certain that that is correct, because immediately you begin to place those numbers of moles of each of those compounds which you'll find. You'll discover that that works out very well. The trial and error method, you need to keep trying and placing numbers of moles in front of any of those chemical compounds to see if it balances on both sides of the chemical equation. That is, on both the left hand side and on the right hand side of that chemical equation. So we're going to use some examples to treat or illustrate what I'm talking about. So let's say, for instance, we have iron 2 chloride plus the chlorine molecule, and then we have iron 3 chloride being formed there. So this is actually not balanced, because though you see the number of iron atoms here are balanced, but for the chlorine which you see here, we have 4 chlorines on the left hand side, but then we have only 3 chlorines on the right hand side. So in order to balance this using the algebraic method, we introduce some values, some letters in front of those places where you should introduce them based on where you see deficiencies. So you know that there is no deficiency for iron here, but when you come to chlorine, there is a deficiency here. So that makes me to put an X in front of the iron 2 chloride. Then I won't put anything here because this is just one atom. Moreover, this chlorine has already been attached to iron here, so there is no much need for me to deal with this chlorine molecule, because chlorine is already here, and it happens to be that this whole expression is dealing with just two elements reacting with themselves. Then on this side I can put a Y, because here is also a place where there is the deficiency, but here the chlorine is already dealt with here. That is why I'm not going to put any letter in front of this chlorine. And moreover, it's only one atom, it's only one element, so that's the reason why I'm not doing too much of putting a letter in front of it. So let's just deal with X and Y. So for the iron molecule, we have X of it on the left hand side of the equation. So this is the left hand side of the equation, and this is the right hand side of this equation. So this is the left hand side. So that's the left hand side. This is the right hand side. So on the left hand side, we have X number of atoms, because we have 1 multiplied by X, and that's going to be X. Then on this side, we have Y number of atoms of iron. Now for chlorine, this side we have 2 multiplied by this X is going to give you 2X plus 2. And on this side, we have 3 atoms of chlorine, but you multiply by this y, so that's going to be 3y. So that means we have 2 equations sticking out here. And the first equation is x is equal to y. So if x is equal to y, I can substitute either x or y for themselves in the second equation. So let me choose to substitute y for x. Since x is equal to y, that means y is equal to x. So I'll put x in place of the y there. So that means we have 2x plus 2 is equal to 3x. Since y is the same thing as x. So we have 2x plus 2 is equal to 3x. That means 2 is equal to 3x minus 2x. Therefore, 2 is equal to x. So we have found an answer already. But because we know that y is equal to x and x is equal to y, that means y is also equal to 2. Since we found that x is 2, it means y will also be 2. That means the 2 things that we need to find, the 2 numbers that we need to find are 2 and 2. So let's place those numbers in front of these chemical equations, in front of those chemical compounds that are needed, and see if that balances out. So we have for x in this place, it should be 2. So that is 2 iron 2 chloride plus the chlorine molecule. Then on this side for y, we have 2. That is FeCl3. So let's check if it balances. For iron, we have 2. And then on the right hand side for iron, we also have 2. And for chlorine, we have 2 multiplied by these 2, that's 4, plus these 2, that's going to be 6. If you multiply these 2 by 3, you have 6 also. So that means this chemical compound is now balanced. We've balanced it with the algebraic method. So the major thing you need to deal with, the major thing you need to ask yourself is to begin to look for the place where there is a deficiency on one side or the left-hand side of that chemical equation. Then you begin to place letters in front of those chemical compounds. Let's try another example and see. Let's say I use methane reacting with oxygen to form carbon 4 oxide and water. So first of all, I look for carbon. This side for carbon here is the same, that's 1 carbon, and here is also 1 carbon. Then for hydrogen, I have 4 hydrogen, but on this side I have only 2 hydrogens. So I can put an X in front of this. And then I look for the oxygen here. We have 2 oxygens here, but on this side we have 3 oxygens. So I can put a Y here. Then if I come here, this has already been settled because we already put letters in front of those elements that are missing. So if I put that there, I can put something like okay, let me see. I can put a Y here. I can put a Y there. Sorry. Let me use rather a Z, because we already have a Y here. So for the carbon, we have X on this side, but on this side we have 1. So that already tells us one answer there. Then for hydrogen, we have 4X is equal to 2Z on this side. Then for the oxygen, we have 2Y is equal to 2 plus Z. Now, but you know that for this case, we already have 4x is equal to 2z, but our x is equal to 1, right? So we can now substitute x is equal to 1 for this second place. That's going to be 4 into 1 is equal to 2z, and 2z is equal to 4. That means z is equal to 4 divided by 2, which is 2. That means z is equal to 2. We've gotten the second. And then for y, we have that 2y is equal to 2 plus z, right? But z is 2, so that is 2y is equal to 2 plus 2. So 2y is equal to 4, and therefore y is equal to 4 divided by 2. And 4 divided by 2 is 2. So that means our y is also 2. So in balancing this chemical equation, we should actually have an x for 1 there. Therefore, I won't put anything in front of the methane. But when I come to the oxygen molecule here, we have that y is equal to 2. So since y is the thing that is in front of the oxygen, I'm going to put 2 there. So we have 2 of that. And then for the carbon 4 oxide, we didn't put anything there, because all the elements that make up carbon 4 oxide have already been considered on this left hand side for the carbon and for the oxygen. So we don't need to put anything here anymore. Moreover, it's easiest to use only 3 alphabets to create your simultaneous equation when you need to solve. It's best. So that for the Z on this side, our Z is 2. So that's going to be 2H2O. So if you look for carbon on the left hand side, that's 1 atom of carbon, and then on the right hand side, that's also 1 carbon atom. And then for hydrogen, we have 4. And if you multiply these 2 by 2 on the right hand side, it's also going to be 4 atoms of the hydrogen element. Now if you come to the oxygen, we have 4 here, and then we have 2 on this side plus these 2 here, so that's also going to be 4. That means this chemical compound is also balanced now. So it's so very easily done, not hard at all. So let's just try a last example so that you can understand it very well. So for the last example, we have ammonia reacting with the chlorine molecule to give the nitrogen with hydrogen chloride. So this is the reaction which you have, and like I said, you first of all check for the first element that has a deficiency on either side of the chemical equation. So on the left hand side and on the right hand side, you need to check that out. So for nitrogen, we have only 1 atom of nitrogen on the left, but on the right, we turn out to have 2 atoms of nitrogen. So there is a deficiency in the nitrogen. Let's look for hydrogen. For hydrogen, we have 3 atoms of hydrogen, but on this side, we have only 1 atom of hydrogen. So obviously, you can see that this whole compound has to be increased. So I'm going to put X in front of that ammonia. Then for chlorine, we also find that there are 2 chlorines in this place, but on this side there is only 1 chlorine. So I'm going to put a Y here. And then nitrogen has already been dealt with in this place, so I'm not going to put anything there. But then I'm going to put a Z for HCl. So now let's form our simultaneous equations from here. So for nitrogen, on the left hand side, we have 1 multiplied by X. So that is X atoms of nitrogen. Then on this side, we have 2. So already we know what our X is. Our X is equal to 2. But then for hydrogen, we have 3 multiplied by X, which is 3X. Then on this side, we have Z. Then for chlorine, on this side we have 2Y, but on this side we have Z. So this is what we have. So what you're going to do, this is the first equation, this is the second, and this is the third. But it turns out to be that we already know what our X is. Our X is equal to 2 from equation 1. So you are going to substitute that X equal to 2 in equation 2 to see what your Z is going to be. So we have our X is equal to 2 in the first place. Then substituting into equation 2, That's going to be 3 multiplied by 2 is equal to Z, and therefore Z is equal to 6. So we already know what our Z is now. Our Z is equal to 6. And then lastly, we're substituting this Z equal to 6 into equation 3 to know what our Y is going to be. So we now have 2Y is equal to 6. And therefore Y is equal to 6 divided by 2. So Y is equal to 3. So from here you can see that we have found what our X is, what our Y is, and what our Z is going to be. So let's place that in front of those places where those letters were. So for X, we have 2 there. So that's 2 moles of ammonia. And then for Y, we have 3. So that is 3 moles of the chlorine molecule. Then we have the nitrogen molecule there. Then for hydrogen chloride, we have 6 moles of hydrogen chloride. So if you try to balance, on this side you have 2 of nitrogen, and on this side we have 2 of nitrogen. So nitrogen is balanced. For hydrogen, we have 3 atoms multiplied by 2. That's going to be 6. Then on this side we have 6 also. And then for chlorine, we have 6 there. And for chlorine here, we also have 6. So now you can see that this is also balanced, as you can see that clearly well. So balancing of chemical equations using the algebraic method is very simple, it's very easy, and is most advisable to use because it's not always that you can actually get the answer using the trial and error method, just trying to put numbers of moles in front of any of those chemical compound which has a deficiency on either side of the chemical equation. So it's as simply done as that. You can now try some other equations. You can form chemical equations and try to balance them on your own, or look for chemical equations from textbooks and try to balance those on your own. So here again is the A1 Science Tutor. Don't forget to subscribe to this channel, and don't forget to click the like button and the notification button. Also help me share this video to your friends and colleagues. Thank you.